All right, this is Pluto, some early images. So now we're moving into our solar system. The very outer edge of our solar system are a series of satellites. The first that they saw was the largest, which is Pluto, but we've developed telescopes now that can see that around Pluto there are other smaller satellites, Charon, Nix, and Hydra. The first that they observed around Pluto is Charon. And if you know your Greek mythology, you see the connection there, right? Pluto's what?
Hades.
Yeah, Hades, the god of the underworld. Who's Charon? Charon is the ferryman.
That's right.
In the boat that goes across the river Styx into Hades. And so they're still pulling names from Greek mythology. The next planet is Neptune, Uranus and Neptune. They're called the twin planets because they are very similar in appearance and makeup. I think they have a higher concentration of methane in their atmosphere, hydrogen, helium, methane, and the methane is what gives them that strange bluish color. The atmospheres change through time. You can see different images, and so the surface features in their atmosphere are actually storms. Those are hurricanes that are forming in the upper atmosphere. Uranus actually has rings, but they're very faint. It wasn't until we sent probes out that got close enough to see the rings like Saturn. This slide looks like it's in sideways, but it's not, because Uranus doesn't spin around the sun. It rolls like a barrel, which is kind of weird. Not sure what happened. Maybe a comet came through and tipped it over. But all the planets are spinning like tops around the sun, but Uranus rolls. So it's not in sideways. That's the way it should be. If you look at the nebular hypothesis, as the material around the sun is spinning and forming these eddies, all of that would have been in the plane of the ecliptic. Therefore, the objects themselves have been spinning like tops with their axis of rotation perpendicular to the plane of the ecliptic. And what's even more interesting, if you imagine a top spinning, when the top spins, it's usually spinning like this, and what happens when it slows down? Starts to wobble, doesn't it, like this? And that's what the planets are doing. The Earth, that's what causes the tilt. The reason it's tilted 23 degrees is because it's beginning to spin like this. So eventually it'll just stop spinning completely. And when I was in paleontology, I read a paper one time. It was very fascinating. It was on oyster shells. They had taken fossil oysters that supposedly are millions of years old, and they spaced them out. So they have oysters today. They have oysters that lived 60,000 years ago, 100,000 years ago, a million years ago, 100 million years ago, 300 million year old oysters or whatever. And they had these different oysters. And the thing is, when you cut through them, you can see the tidal cycles because they're adding on. They're building their shells. And so you can see tidal cycles that represent daily changes. And then you can see seasonal changes from summer to winter, because in the wintertime, the oysters are producing less than in the summertime. So you can see summer-winter cycles, yearly cycles, and you can see tidal cycles on a daily basis. So you know what you can do?
Similar to a tree ring.
Yeah, like tree rings, but only on a much more defined basis, because a tree ring is just a yearly cycle. But with oysters, you get tidal cycles, which are daily cycles and yearly cycles. So you know what you can do, right? You can determine how many days there are in a year by looking at these accretion levels or layers on the oysters. And so in this study, they looked at recent oysters, and they determined that on average you get about 360 days per year. And then as they started going back in time, they saw a progressive increase in the number of days per year. So you know what that means? If there's more days per year, what's happening to the Earth's rotation? It's speeding up, right? Which is exactly what you would expect if you have the top scenario. It's spinning really fast, more days per year, and it's beginning to slow down. It's beginning to wobble. And so it fits the same type of scenario, that the Earth is like a top. And it was spun at some distance past. It was spun really fast, and now it's slowing down. Therefore, there are fewer and fewer days, rotational cycles, in year, which is the revolution around the sun.